Okay, so I think we are live. Welcome to Spatial Spotlight, this series of weekly webinars that we have in Carto. I am Diego Vicente. I am part of the data science team here in Carto, and today I just wanted to show you a quick example on a new functionality we have been developing, which is called Spacetime Getis-Ord. It's used to compute hotspots, but it also takes into account a time variable that is present in the data. Let me show you super quick. First off, this is the whole pipeline of this example. I'm going to walk you through the steps. The first important block is the input data. It's basically a data set with car accidents in Barcelona during the year 2018. Yes. This is open data. It's available in the open data portal in the Barcelona City Hall. And the preprocessing we have to do today is minimal because we are basically only going to count the accidents. Each row is an accident, so it's super easy to do. The only thing we have to do is take the original data, which is almost like 10,000 records, and we have to read the geometry. The original geometry is stored in a string in this table, so we have to read it from well-known text to an actual geometry in the query. And after that, we simply snap it to H3. So I can show you super quick here. This is the original data. It's basically all the accidents covered in Barcelona. And yeah, once we snap it into H3, we are still not plotting any metric into this grid, but we can see how the cells cover most of the city. So yeah, this is the original data. We could argue that this is already, like, we are already doing a spatial analysis, but plotting just a cloud of points into a map is not really super insightful or actionable. You could argue that if we play with transparency, if we take care of overlapping points, maybe we could extract some information, but it's not super reliable. We could also plot it using H3, but that's going to be probably in some cases a bit noisy, and we can do better. So the first thing we're going to do is just for us to compare, we are going to compute the hotspots as we have been usually doing it using the Getis-Ord function. This is a function that is available in Analytics Toolbox for SQL. This has been available for quite some time now. And what it does is basically, given a grid, both quad-bin or H3, it takes the surrounding cells for a cell, and it computes this concentration metric that I'm probably going to refer to later as the temperature. So the higher the metric, the more concentration in that cell and the surrounding area, and the lower the metric, the lower concentration in that cell and the surrounding area. The size of the surrounding area is something that we define as a parameter. It's usually referred to as the K-ring. And yeah, this is super simple. We simply give the parameters and the function does all the heavy lifting for us. What we're doing here is grouping by H3 and then counting the accidents. Once we have that, we call the function and we save the table, and we can check the results in the map. And this is how it looks. It looks better already. Now we can see that only the relevant cells are being plotted, because this function not only gives you the temperature metric, it also gives you a p-value, which lets you filter by statistical significance. So all the cells whose p-value is not good enough, we simply don't plot, and we keep only the ones that we know that are relevant to the study. And yeah, we can see that mainly the whole city center of Barcelona is a big hotspot, also the port, and we have two cold spots, one in the north and one in Montjuic. This is kind of insightful, but still, we can do better. This is not something that is going to be super actionable anyway. And for that reason is what we did this new function, which is the Spacetime Getis-Ord. So if the regular Getis-Ord worked by taking the surrounding cells of a focus cell, this time we are not only taking the surrounding area, we are also taking the surrounding area and the surrounding timestamps. So for example, you have a cell and a neighboring cell, the neighboring cell is going to be included just like the same cell the next week or the next day or any frequency that I desire. So in a way, what we're doing is taking the 2 dimensions of the map and adding a new dimension of the time to compute this surrounding area. This is kind of complex, but we're doing this for you so you don't have to worry about it. This time we simply have to create a new column that is the week. We're going to do it by week. Our frequency is going to be weekly. We simply use the sequence function to get the week for each accident, and then we group by both the H3 cell and the week. And now we're ready to call the function. This is a custom component, so I'm going to show you the SQL function because the custom component is still not ready. We're going to have it ready soon enough, but still, now the way to do it is calling the SQL function. It's easy enough. We simply have the input table, the output table where we want it to be stored, the type of read, and the metric and the spatial k-ring size, and the frequency and the temporal k-ring size. It's not technically a k-ring, but I'm going to call it a k-ring anyway. And these are the 2 kinds of kernels, both the spatial one and the temporal one. So yeah, we are doing this kind of convolution in both ways, in both dimensions now. And what we have now is the same table of having the H3 cell, the metric, the temperature, and this is statistical significance, the p-value, but we also have a date. So we have a new dimension to plot, and this gives us a whole new array of things to do. For example, we can plot the temperature of each point and how often they appear. So now we can see that, yeah, we still have the city center of Barcelona, which is the highest concentration of accidents, but we also have the amount of times that this cell appears as a hotspot. So for example, we can check here that there's this tiny cluster of 6 cells, which are not extremely hot, like they don't have like that much of a concentration, but they appear often as a relevant enough concentration of accidents. So we also have Santa Coloma in the north, which has like a fair amount of accidents now that were not even relevant in the whole year picture. And yeah, still we can see how the city center of Barcelona is probably the one with the with the most concentration of accidents. However, we can also split the data. For example, we can plot a side-by-side comparison of the hotspots that appear in winter and in summer. So here, for example, in the left side, we have the winter, and the right side, we have the summer. And we can see how it's kind of similar, but you can still appreciate some differences. For example, in winter, the city center is like the highest concentration of accidents, but it's more spread out. And also the north is like relevant now in the analysis. However, in summer, basically the whole concentration of accidents appear in the zones which the most touristic appeal in the city center of Barcelona. So we can do this kind of split analysis to check only the relevant information for our analysis. Or we can go one step further and just explore the data using SQL parameters. We can just filter the weeks to check the hotspots that we're interested in. For example, here, we are seeing just the first 2 weeks of March, which are fairly usual for the season they appear in. But if, for example, I plot the next 15 days, which include Easter, we can see how the distribution changes, and the concentration of accidents gets super hot in the parts with touristic appeal because of the holidays and people going to Barcelona, probably getting more congested in this side of the city. And yeah, that was basically it. It was super quick, but we have been making an active effort to make this simple to use, so not really much else to show you. But if you have any questions or any doubts, please let me know in the comments, and I'll try to help you out. And yeah, once again, thank you for watching and for joining the stream, and see you soon.